All right, here we are at 6.6 day 1. Today we're going to be solving exponential equations. In order to do that, we're going to have to use logarithmic functions. So first thing we're going to look at is just going back and rewriting some exponential and logarithmic equations in different forms in order to help us solve. You'll notice on the first two questions, anytime you have the variable in the exponent, in order to solve that, you're going to have to rewrite that problem as a logarithm. Or in the case of question number 2, since it has a base of e, you're going to have to rewrite it as a natural log. So let's just look at question number 1 here. If we have 2 to the x minus 1 equals 5. We don't know how to find x just with any guess and check or anything like that. So what we need to do is we need to rewrite it as a log, and that will bring that variable out of the exponent. If we have log base 2 of x minus 1 equals 5, if we rewrite that problem as a logarithm, we'd have log base 2 of 5 equals x minus 1. That brings that whole x minus 1 down out of the exponent. So we have log base 2 of 5 equals x minus 1. We don't want x minus 1, we just want x. So we just need to add 1 to both sides. And when we go and we put this into our calculator, if we have log base 2 of 5, we want to make sure we're keeping those parentheses closed when we're done so it doesn't add 1 to the 5 and then take the log, plus 1 equals x. If we put in our calculator log base 2 of 5, we can either hit enter and then plus 1, or we can just close that parentheses and add 1. We should get that x equals 3.322. And again, we always round 3 places plus the decimal unless it says otherwise in the directions. On question number 2, we have e to the negative 2x equals 11. Okay, so we have the negative 2x is in the exponent. In order to bring that exponent down, we're going to have to use the natural log, because the natural log is how we undo e. So we would have the natural log of 11 equals negative 2x. Okay, because remember that's basically like a log base e that we're looking at. Log base e instead is the same thing as natural log. So we have natural log of 11 equals negative 2x. We don't want negative 2x, we want x. So we're going to divide both sides by negative 2. And again, I've said this bunches of times, we need to make sure that that 11, when you're taking the natural log, stays in the parentheses before you divide by negative 2, and we should get that x equals negative 1.199. Okay, and then on question number 4, we have log base 2 of x plus 5 equals negative 1. Well, if we have a log, it's written as a log, and we need to figure out what we're taking the log of. Taking the log of x plus 5, we're going to have to rewrite that as an exponent, which means we would have 2 to the negative 1 equals x plus 5. That's just rewriting a log as an exponent. We have done that lots and lots of times. If you have 2 to the negative 1 equals x plus 5, we don't want x plus 5, we want x. So I'm going to subtract 5 from both sides. If you put it into your calculator, if you want to, 2 to the negative 1 is 1/2. But if you want to put it into your calculator, you can go 2 to the negative 1 minus 5, and you should get that x equals negative 4.5 or negative 4.5. Okay, on question number 5 here, we have the natural log of 2x. That's like log base e of 2x. So that would be e to the third equals 2x. Again, we're wanting to get x all by itself, so we don't want 2x, we want x. And if I divide both sides by 2, remember e is just a decimal value, it's 2.718, so a button on your calculator. So you're going to want to hit e to the third power, and then you're going to divide that by 2, and you should get x equals 10.043. So we're going to actually use some of these ideas and then today and tomorrow with 6.6 to solve these equations. Okay, so all we have here is just our basic question. what we're going to be doing today, tomorrow. Today we're going to be solving exponential equations. Tomorrow we'll be solving logarithmic equations. If you're looking at exponential equations, okay, basically if you have bases that are the same, the exponents are going to be the same as well. So in the example up here where it says 3 to the x equals 3 to the 5th, we have bases that are the same. We have a base of 3 over here, we have a base of 3 over here, which means our exponents are going to be equal to each other. So we'd have x equals 5. Okay, we're just going to use that idea and expand on it here today. So let's look at what we have here. On letter A, we have 7 to the 3x plus 5 equals 7 to the 1 minus x. Again, that on the last slide said if you have the same bases, I have a 7 and I have a 7. Oops, I didn't mean to cross that out. If I have a base of 7 and a base of 7, that means our exponents are the same. So if I have 7 to the 3x plus 5 equals 7 to the 1 minus x, that means that 3x plus 5 equals 1 minus x. And again, all it is now is just a multi-step equation getting x all by itself. So I'm going to add x to both sides. And I get 4x plus 5 equals 1. If I subtract 5 from both sides, 4x equals negative 4. Divide 4 on both sides, I get x equals negative 1. And we can always go back and just double check that. If we put it in there, we had 3x plus 5, 3 times negative 1 is negative 3. Negative 3 plus 5 is 2, so 7 squared would be on the left. And then if we had 7 to the 1 minus x, 1 minus negative 1 is 7 to the 1 plus 1, which is also 7 squared. So it would work out. Moving on to letter B, we have 5 to the 2x minus 6 equals 5 to the 3x plus 5. Again, we have bases that are the same. If the bases are the same, the exponents are equal to each other. So I can say 2x minus 6 equals 3x minus 5. And again, now we're just having a multi-step equation. I'm going to subtract 2x from both sides. Negative 6 equals x minus 5. If I add 5 to both sides, I get x equals negative 1. If you want to take a minute, pause the video, you can go back in and substitute negative 1 into the exponents up there, and you should get a true statement. Letter C is a little bit different because if you notice, we have 4 to the x minus 3, and we have 16 to the x minus 5. Well, we know a little number sense here. We can rewrite 16 using 4. So if we just rewrite that equation, I'm going to rewrite the left is 4, oops, write an x there, to the x minus 3 equals, well, 16 is just 4 squared. So I'm going to rewrite that as 4 squared to the x minus 5. This is where we need to remember some of our properties with exponents. On the left, we have 4 to the x minus 3. That's all good. On the right, we have, so I'm going to rewrite that there, 4 squared to the x minus 5. If you remember our exponent rules, if we have an exponent on the inside and outside, we multiply those exponents. So we'd have 4 to the 2x minus 10. All I did was I multiplied 2 times x minus 5. Now we have a problem where our bases are the same, so we can set our exponents equal to each other. So we'd have x minus 3 equals 2x minus 10. Again, I'm going to subtract x from both sides. This is just solving an equation. Negative 3 equals x minus 10. If I add 10 to both sides, I get x equals 7. That one just required a little bit of manipulating of our numbers to get it so that we could work it out a little bit easier. On letter E, this one's not bad. We have bases are the same. E to the 2x equals e to the 3x minus 1. which means 2x, 2x equals 3x minus 1. If we subtract 3x from both sides, negative 1x equals negative 1, which means x equals 1. All right, letter E is a little bit like letter C, the one right above it, where you have a base of 6 and you have a base of 36. Well, the base of 6 is fine. So I'm going to write that again, 6 to the 2x minus 6, that's all good. But I need to rewrite 36 so it has a base of 6. Well, that's just 6 squared. I put that in parentheses because that 36 I'm rewriting. And I'd have 3x minus 5. Again, inside and outside the parentheses. Inside, outside the parentheses means that we multiply those exponents. So I'd have 6 to the 2x minus 6 still over here equals 6 to the 6x minus 10. All I did was I distributed that 2 to the 3x minus 5. Which means bases are now the same, so I can set the exponents equal to each other. So 2x minus 6 equals 6x minus 10. If I subtract 2x from both sides, negative 6 equals 4x minus 10. If I add 10 to both sides, divide by 4, I get x equals 1. Okay. Letter F is just a little bit tricky. You have to remember a couple of your rules with exponents. On the left, we have a base of 10 to the x power. On the right, 1/10, if you write it as a base of 10, is 10 to the negative 1. So that is being raised to the x minus 3. So my 10 to the x on the left is all good. It stays there. If I have my base of 10, I'm going to distribute that negative 1. So I get 10 to the negative 1x plus 3. Our bases are now the same. So I get x equals negative 1x plus 3. If I add x to both sides, I get 2x equals 3. And x equals 3/2 or 1.5 or 1.5. Okay, so what we have here is just a few more examples of solving equations where variables are in the exponent. And if you notice, I put a little note down at the bottom that if you're asked to solve an equation and the variable is in the exponent, you must rewrite it as a log, or if it has a base of e, you need to rewrite it as a natural log. So we have a couple of examples of each kind of those. On letter A, you have 7 to the 5x equals 12. Okay, so we have no bases that are the same. There's nothing else that you can do besides just rewrite it as a log. So that's just things that we've done already, where if you have 7 to the 5x equals 12, that's a log base 7 of 12 equals 5x. That is just redoing the same process we have done multiple times. And again, we don't want 5x, we want 5. So we're going to divide both sides by 5. Again, like I said many times, make sure you enclose that 12 in parentheses, so you're taking the log of 12, getting that answer and dividing it by 5. And if you put that into your calculator, you should get that x equals 0.255. Very similar question here. You have 11 to the 6x equals 38. All I have to do is rewrite it as a log. I would have log base 11 of 38 equals 6x. Again, I don't want 6x, I want x, so I'm going to divide the whole thing by 6. When I put that into my calculator, I should get that x equals 0.253. And as I'm doing these problems, I encourage you to pause the video, go try to finish the problem on your own, try the next one on your own by yourself first, and then see if I explain it and you did it correctly or not. On letter C, we have 3e to the 4x plus 9 equals 15. Several things going on here. We've always said that before we start doing anything with our log or natural log, we need to get that log or e natural log all by itself. So in order to get e to the 4x by itself, the first thing I'm going to do is I'm going to subtract 9, and I get 3e to the 4x equals 6. Again, I don't want 3e to the 4x, I just want e to the 4x. I'm going to divide out that 3, and I get e to the 4x equals 2. Next, I have a variable in my exponent and a base of e, which means I need to use natural log in order to solve that, which means I have the natural log of 2 equals 4x. I don't want 4x, I want x, so I'm going to divide everything by 4 and put it into your calculator. If you do the natural log of 2 and divide that by 4, you should get 0.173. Letter D is similar to that. We have 2e to the 2x minus 7 equals 5. I'm going to add 7 to both sides. 2e to the 2x equals 12. If I divide 2 on both sides, I get e to the 2x equals 6. Again, I have a base of e, so I'm going to use natural log to move that 2x out of the exponent, which means I have the natural log of 6 equals 2x. Divide both sides by 2. X should equal 0.896. Quite often we represent growth of animals or plants or things like that exponentially, which this is an example of that, and then how we can actually solve it. Again, we have a story problem. The length in centimeters of a hammerhead shark can be modeled by the function L is the length of the shark equals 266 minus 219 e to the negative 0.05 t. Okay, where t is the age in years of the shark, L is the length in centimeters. And what it's asking us to do is how old, so we're trying to solve for t, is a shark when the length, how old is the shark when the length is 175 meters, or excuse me, 175 centimeters, and round your answer to the nearest tenth. Well, they want us to find t, and they give us L. So we would have L is 175, so we'd have 175 equals 266 minus 219 e to the negative 0.05 t. And if we want to solve for t, first thing we need to do is get e all by itself. So we need to get this part all by itself. In order to do that, first thing I'm going to do is I'm going to subtract 266 from both sides. And what do I get? Let me see here. And I get negative 91 equals negative 219 e to the negative 0.05 t. Okay, again, I want e by itself, so I'm going to divide by negative 219. I'm going to round this decimal value to point, and it's positive because you have a negative divided by a negative, 0.4155 equals e to the negative 0.05 t. All right, now we have e all by itself, but we need to get that variable out of the exponent. With the base of e, that means we're taking the natural log of 0.4155 equals that exponent, which is negative 0.05 t. Again, we don't want 0.05 t, we just want t. So I'm going to divide 0.05 on both sides, or excuse me, negative 0.05 on both sides. And if I put that into the calculator, I get that t is approximately 17.6, which means that the shark will be 175 centimeters long after approximately 17.6 years.